Hi everyone. So welcome to Design and Analysis web series. I have posted so many concepts related to design and analysis algorithm like recursive and non-recursive algorithm, greedy algorithm, dynamic and so on. So if you want to know more about this, kindly subscribe and follow.
Hi everyone. Welcome to DA series. So today we are going to see all pair shortest path. So all pair shortest path comes under the Floyd-Warshall algorithm. So here we have taken this algorithm to solve the concept of all pair shortest path. So what is the meaning of all pair? So here consider a graph. So in this graph we are having the 4 vertices 0, 1, 2, 3. So these are all the vertices through via 0 we need to travel to the vertex 1, 2, 3. Similarly, through via one vertex, we need to travel to 0, 2, 3. Similarly, via 2, we need to travel 1, 2, 3. Likewise, we need to travel to all the vertices and we need to find the minimum cost. So that's why this is an optimization problem. We would like to find the minimum cost to travel from source to destination. So through the matrix we are finding the weighted cost of each matrix, each edge from one vertex to other vertex. So this is the given graph and we are having a A0 matrix. This convey the direct path from, so for example consider the 0th vertex. 0 to 0 there is no loop at all, therefore it is represented with the weight of 0. 0 to 1 we have the cost of 3 and therefore it is represented the weight cost as 3. 0 to 2 we don't have any direct path, therefore it is identified as infinitive. 0 to 3 we are having a path and that cost is 7. So likewise from this graph we are finding all the matrix and we have framed a matrix as A0. Now we are going to form a A1 matrix which help us to travel through 0. We shall start it from the initial vertex 0. So this concept via 0 we need to travel from 1 to 3 and therefore what is the cost matrix we need to identify. So the first row and first column will be the same. So what is the first row? 0, 3, infinity, 7, 8, 5, 2. So this will be the same matrix. And we need to find the value of 0, 1. 0, 1. So A of 0, 1. 1, 1. 1. So this value 1, 1. So via 0. So 1 to 0, 0 to 1. We need to find the 0, 1, 0 plus 0, 1. Okay, na? So here we need to compare the value of direct value from this 1, 1. So 1, 1. What is the value of 1, 1? 0. So 0 and we are comparing this whether this is less than or greater than this 1, 0. 8 plus 0, 1. 0, 1 is 3. So definitely the previous value 0 is the minimum value and therefore we are replacing that value with the same value. We are not going to change the any value. Why? Because now we need to find the minimum cost. Similarly we need to find the A of 1, 2. We need to compare that via 0 na. So 1 to 0, 0 to 2. So A of 1, 0 plus A of 0, 2 via 0. Okay, so therefore the 1, 2 is traveling through the 0. So 1, 0, 0 to 2. This 1, 2 has written in such a way. 1, 2, what is the value? 2. So 2 is either less than or greater than, we need to check it out. So 1, 0 is 8. So definitely 2 is the minimum value. So this is infinitive. So we are going to write the same value and we are not taking any of the new value for this one. We are having the old value itself. Why? Because now that is the minimum value. So now we need to find out similarly a of 1 comma 3. So this should be compared with via 0 na. So 1 comma 0 plus a of 0 comma 3. 1 comma 3. So 1 comma 3 is infinity. Whether this is greater than 1 comma 0 is 8 plus 0 comma 3 is 7. So 15. So we can replace this infinity with 15. Why? Because now that is the minimum value compared to the previous value infinity. Therefore that value is replaced. Now we need to find the value of a of 2 comma 1 via 0. So this should be compared with a of 2 comma 0 plus a of 0 comma 1. So 2 comma 1 is infinity. 2 comma 0 is 5 plus 0 comma 1 is 3. So 8. So this is the minimum value. So this can be replaced. So infinity is replaced with 8. So likewise we need to find the value for a of 2 comma 2. So a of 2 comma 2 via 0. So a of 2 comma 0 plus a of 0 comma 2. So we are taking all these values from a0. So 2 comma 2 is 0 less than 2 comma 0 5. So definitely the value this is greater. So 0 comma 2 is infinity. So we can replace the same value. Okay. So here we need to find the next value of a of, we will find the next value a of 2 comma 3. This is via 0 na. So a of 2 comma 0 plus a of 0 comma 3. So 2 comma 3, what is the value of 2 comma 3? 1. So 1 is less than or greater than 2 comma 0 is 5. So definitely the previous value only it is minimum. Therefore we will have the same value. So likewise we need to find the value for a of 3 comma 1. So via 0 na. So a of 3 comma 0 plus a of 0 comma 1. 3 comma 1, what is the value? Infinity. So definitely this is greater. 3 comma 0 is 2 plus 0 comma 1 is 3. So what is the value? 5. Definitely this is the minimum value. So we shall replace this value with the 5. Again one more infinity we are having for the next value 3 comma 2. So 3 comma 2. So a of 3 comma 2, a of via 0. So plus a of 0 comma 2. So 3 comma 2 is infinity. So definitely this is greater. So 2 plus 0 comma 2 is infinity. So 0 comma 2. 0 comma. So here also we are having the infinity. So this will be replaced with the same old value. And 0 na, definitely 0 plus 3 comma 0. So 3 comma 0 here you are getting 2. So definitely that value will be maximum. So we can have the old value 0. That value will be the same. The previous value will be the same. So now this is the minimized matrix A1. So now we need to consider these matrix and we are going to travel through the 1. So through 1, 0, 1 to 2, 1 to 3. So the second row and second column will be the same. Okay, we need to find the next matrix A, 2, and that matrix will be 0, 1, 2, 3, 0, 1, 2, 3. So here this will be the same. 8, 0, 2, 15. 3, 0, 8, 5. So this second row, second column will be same. We need to find the remaining value. So what is the remaining value? How we can find it out now? So next we need to find this value a of 0 comma 0. This is via 1 na? So via 1. So a of 0 comma 1 plus 1 comma 0. 0 comma 0, here we are having 0. So 0. So definitely this will be the minimum. 0 comma 1 is 3 plus 1 comma 0 is 8. So definitely we need to keep the previous value 0 only. So why? Because na that is the minimum value. A of 0 comma 2 via 1. So a of 0 comma 1 plus a of 1 comma 2. So 0 comma 2. 0 comma 2 is infinity. Infinity 0 comma 1 3 plus 1 comma 2 is 2. So what we can have? 5. So this value can be replaced with the 5. So similarly we need to find the remaining value. So now we have to consider only this matrix, not this matrix. Okay, we need to consider A1 only. We need to consider that matrix only. So now what is the next thing we need to find? A of 0 comma 3. So we need to compare, and this is via 1. So 0 comma 1 plus a of 1 comma 3. So 0 comma 3 7. So whether this is greater, 0 comma 1 is 3 plus 1 comma 3 is 2. So 5. So this is 0 comma 1 3 1 comma 3. So we need to consider 0 comma 1 is 3 and then 1 comma 3 is 15. So this is not 2, this is 15. So definitely we are having a greater value. So we will replace with the same value. So now we need to find the value for a of 2 comma 0 via 1. So a of 2 comma 1 plus a of 1 comma 0. So 2 comma 0 is 5. So 5. 2 comma 1 is 8. So 8 plus what is the value? 8. 2 comma 0. 2 comma 0 is 5. And then what is the value? A of 2 comma 1 is 8. So 8 itself it is becoming the maximization. So 1 comma 0 is also 8. So the old value we can have the previous value 5 itself we can have. So similarly we need to find the value for a of 2 comma 2. So 2 comma 2 via 1. So we need to compare the value with 2 comma 1 plus a of 1 comma 2. So 2 comma 2. So 2 comma 2 is 8. So 8. 2 comma 1 is 8 plus, so definitely this value is also 2 comma 2. So this is also previous value. So previous value is 2 comma 2 is 0. So this value is 0. So definitely it will be going to be the maximum value. So we shall plus 2 na? So we shall have the same value, old value, previous value. So now we need to find 2 comma 3. So a of 2 comma 3 via 1. So a of 2 comma 1 plus a of 1 comma 3. So 2 comma 3. 2 comma 3 is 1. So 2 comma 3 is 1. Which is 1 is minimum, we need to find it out. 2 comma is 8. So definitely again it will become maximum. So we will have the old value, previous value. So now we need to find the value for 3 comma 0. So 3 comma 0 and the remaining value we need to find it out by using this previous matrix. So what is the value? A of 3 comma 0 via 1. So 3 comma 1 plus a of 1 comma 0. So what is the value of 3 comma 0? 2. 3 comma 1 is 5. So definitely it is becoming maximization. 8. So we will have the previous value itself 2. So now we need to find the value for 3 comma 2 via 1. So a of 3 comma 1 plus a of 1 comma 2. So 3 comma 2 is infinity. So we can replace the value. So 5, 3 comma 1 is 5 plus 1 comma 2 is 2. So 7. We can replace the infinity with the value 7. So here we are having 0. So any value is added to its 3 comma 1 5. So it will increase the value. We will have the previous old value itself. So this is via 1. Similarly, we need to find the value for via 2. Here I have written the value for third row, third column. Third row, third column will remain the same. Why? Because now we are going to travel via 2. Here we need to find the value of a of 0 comma 0 via 2. So a of 0 comma 2 plus a of 2 comma 0. So compare the value of 0 comma 2 is 5. So definitely it is going to be maximization. We will have the previous value 0. So here next a of 0 comma 1. This is compared with via 2 na. So 0 comma 2 plus a of 2 comma 1. 0 comma 1 is 3. 0 comma 2 is 5. So we'll have the same value. So 3, same value. So now we can have the next value. We need to find it out. A of 0 comma 3 via 2. So a of 0 comma 2 plus a of 2 comma 3. 0 comma 3 is 7. 0 comma 2 is 5. 2 comma 3 is 1. So here the value is reduced to 6. So we are having now the new value we are getting it is minimum value. So that value is replaced. So now 1 comma 0 via 2. So a of 1 comma 2 plus a of 2 comma 0. 1 comma 0 is 8. 1 comma 2 is 2. 2 comma 0 is 5. So we are getting 7. So this value is also minimized. Similarly, we can find the remaining value also. So I'll write all the remaining value. I'll find it out and I will write all the value. I calculated all the remaining value and the values are remaining the same value. Only this 7 we are getting the minimized value, and instead of 15 I am getting the minimized value as 3. So the remaining all same only. Now this is considered as via 2. So we need to consider the current matrix. This matrix we need to frame the A4 0 1 2 3, the final matrix, which is going to give the minimum path. So 2 5. So this third row, the last row, last column, fourth row, fourth column, this will be the same, and we need to find the value of remaining. Likewise, a of 0 comma 0 via 3. A of 0 comma 3 plus a of 3 comma 0. 0 comma 0. So definitely 0 comma 3 6. So definitely this will be the minimum. So we can replace this value with the previous value. Likewise, we need to find the value of a of 0 comma 1 via 3. So a of 0 comma 3 plus a of 3 comma 1. 0, 1, 3 compared with 0, 3, 6 plus 3, 1, 5. Definitely that is the maximum. We can have the previous value, old value. So now we need to find the value for next one. So a of 0, 2 via 3. So a of 0, 3 plus a of 3, 2. 0, 2, 5 less than, so definitely it is going to be the maximum plus something, na maximum only. So we will have the previous value. Similarly, we need to find the value for next value, that is a of 1, 0 via 3. 1, 3 plus a of 3, 0. 1, 0, 7. 1, 3, 3 plus 3, 0, 2. Here we are getting the minimum value. This can be replaced. 5 can be replaced with 7. Okay. 0 definitely the remaining value we will get it as maximum value only. When we consider a single value, that will get be the maximum value. See here 1, 1. So 1, 0 is 7. So definitely it will become maximum. So we can have the previous value. 1, 2 via 3. So 1, 3 plus a of 3, 2. 1, 2 is 2. Definitely this is the minimum. 1, 3 is 3 plus 3, 2, 7 maximum. So we will have the previous value. So likewise I will find the, here I have found the answer for the last row. We are getting the same value and this is replaced with these value, and this is the 3, 6, 0, 1. So 5 is replaced with the 3, 8 is replaced with the 6, the remaining all the same value. So we are getting the minimized value. So now this is the final matrix. This is the final matrix and this is the shortest path, all pair shortest path. So this is the answer for all pair shortest path. So this can be written in a generalized formula such that when we consider a to the power of 1, we need to construct that particular matrix. If you take K, which matrix we are considering? A to the power 0 matrix only we are considering. Therefore, that can be written as AK minus 1. The same value which is available in that existing matrix is taken as A of A power K minus 1 I comma J, comma, and the remaining one is via na, so that via which vertex, that can be considered as I comma K plus K comma J, in which matrix? A to the power of K minus 1. So this can be written in the generalized formula. So now how many looping statement we will have? K, one for K, I and J. So 2n the looping statement we will have. We need to execute these looping to construct the particular matrix. So big O of n cube is the time complexity for Floyd-Warshall algorithm. Okay, thank you.